In previous classes, we studied about geometrical isomers. Geometrical isomerism. So broadly, these are of three types: cis-trans, E and Z, and third, lesser known, Syn-Anti system. So these two we have already discussed. Now we'll see this Syn-Anti. It's a very small concept, not used anymore, but it is still found in some of the old textbooks and some research papers. So let's discuss this. Syn-Anti is used for the system which have carbon nitrogen double bond. Now all of us know that carbon has the ability to form three bonds and it has a lone pair. So this nitrogen will always have a lone pair and something attached here. Okay. Similarly, this carbon will have two different groups attached. Now the condition is, let's say here X and Y group are attached and here A is attached. So your X and Y should always be different. They cannot be the same groups. Then only this compound will show Syn-Anti, or you can say this compound will show geometrical isomerism. Okay, now how to assign the Syn-Anti? So it is very similar to EZ nomenclature. You if the higher priority groups are on the same side, let's say that Y and A are higher priority group, on left and right side respectively, then what will happen? Then we will call our compound as Syn. Okay, and X and A, if X and A are high priority groups, then we will call them anti. Okay, so what in short what I am saying is, if higher priority groups are on same side, then our system is Syn. If high priority groups are on different side, then we call it as anti. Now how do we assign the priority? Assigning the priority on the right hand side, or you can say on the nitrogen side, is simple. Whatever the group is attached, this group will always be high priority group. The lone pair will have lesser priority. This lone pair will always have lesser priority. This group will always have higher priority. Now for X and Y, what you will do, you will follow the priority rules used in the CIP rules. Okay, so whichever group will have priority, based on that you can assign the Syn and Anti. So let's take some example. Let's say we have this CH3, a lone pair, CH3Cl. Okay, now we have to assign whether it's a Syn or an anti compound. So on the right hand side, the methyl group is higher priority group. On the left hand side, your chlorine is high priority. So both the high priority group are on the same side. Let's say same side of the double bond. This is the double bond. So both the high priority groups are on the same side. So this is Syn. Similarly, if you have a group like this, then these two these two are higher priority groups which are present in the opposite sides, so we will name them as anti. So this is the concept of syn and anti. This is only used in the system which have carbon nitrogen double bonds.